Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 13 times x minus 2. For the math knowledge question, they give you the graph of f of x here, and they want to know about g of x, which they say is the graph of f of x shifted up by 4. It just takes it and moves it up by 4. And it wants to know, in between negative 5 and 15, where does it equal 0? Well, for f, it equals 0 at 1, 2, 3 places. But whenever we shift the graph up of f of x, this is f of x. And whenever we take it and pull it up 4, which will put it about right there, this one on the right is no longer going to be touching the x-axis, so it's not going to be equal to 0. But it's still going to be these two. So it'll be at 2 places. So we're looking at lesson 12 today. We're going to look at sum and difference identities, double angle identities, half angle identities, and then graphs of log functions. All of this should be reviewed from pre-calculus with Dylan Trig more. So hopefully you'll understand and remember your sum and difference identities, your double angle identity, your half angle identities, and then log function graphs. So these are the sum and difference identities. If you took me last year for pre-calculus, you should have these memorized. If you've forgotten them over the summer, or if you did not learn them last year, you do need to know them. They're not going to be given to you on a test, so if you need to use them, you just have to have them from memory. Sine of A plus B and sine of A minus B are identical, except for the plus and the minus. So sine A cosine B, cosine A sine B. And if this is plus, this one's plus. This one's minus, that one's minus. For cosine A plus B and cosine of A minus B, they are flipped. So the plus goes with the minus, and then the minus goes with the plus. But other than that, they're identical. Cosine A, cosine B, sine A, sine B. So you need to make sure you learn those. The book loves this tip, and I think it's funny. You can do this if you would like, or you can just make note cards, or you can just stare at them. Don't just put them under your pillow and hope that you're going to learn them through osmosis, though. That's probably not going to work. It says students should practice writing this list of identities several times daily until they can be reproduced in less than 30 seconds. Writing these is also suggested as a first step for taking trig-oriented exams, because these identities are used often and you use them to develop other identities. So they say write them several times a day until you can get them within 30 seconds. I don't care what method you use, but you do have to learn these. Alright, so we're going to simplify sine of theta plus pi over 4. So the first step you want to do is to write down your identity you're going to use. So we're going to be using the sine of A plus B. Sine and it's plus. So that's how I know I use sine and A plus B. And so it is sine of A cosine of B plus cosine of A sine of B. And then we're going to replace our A and our B with theta and pi over 4. So we're going to have sine of theta plus pi over 4. So our A is going to be theta, and our B is going to be pi over 4. And then you can simplify. Sine of theta we can't do anything with, but we can figure out what the cosine of pi over 4 is. That's the same thing as the cosine of 45 degrees, which is square root of 2 over 2. Again, cosine of theta we can't do anything with. The sine of pi over 4, the sine of 45 degrees is, again, square root of 2 over 2. And so you can leave your answer like that, or you can factor out the square root of 2 over 2. And so either one of those would be okay for your answer. Now we're going to find the exact value of cosine of 15 using a trig identity and the fact that 60 minus 45 equals 15. So basically, you're asked to find the cosine of 60 degrees minus 45 degrees. So we're going to use our cosine identity. So we're going to be using the cosine of A minus B, which is going to be cosine of A, cosine of B, plus sine of A, sine of B. And again, we're going to replace our A and B with 60 and 45 degrees. So we're going to have cosine of 60, cosine of 45, sine of 60, and sine of 45 degrees. And then you're going to simplify this. So cosine of 60 is 1/2. Cosine of 45 degrees is square root of 2 over 2. Sine of 60 is square root of 3 over 2. And sine of 45 is square root of 2 over 2. And then if you multiply, you get square root of 2 over 4 plus square root of 6 over 4. And so you can make that one fraction with a denominator of a 4. So I have square root of 2 plus square root of 6 over 4 for my answer. Now you can actually use the calculator to check and make sure that this is correct, not to get your answer. We want to be in degrees, which we are. So the cosine of 15 gives me that decimal. And if you do the square root of 2 plus the square root of 6 divided by 4, you should get the exact same decimal. And so you can check and make sure that yes, that decimal is right. But if you give me this decimal as your answer, it's going to be marked wrong. So make sure you actually work it out by hand, and then you can use calculator just to check and make sure that, yeah, that does work. Okay, so now we're going to develop an identity for tangent of A plus B. So we know that tangent is the same thing as sine over cosine. So the tangent of A plus B is the same thing as the sine of A plus B over the cosine of A plus B. So we start with that. And then we're going to replace our sine of A plus B with sine of A, cosine of B, plus cosine of A, sine of B. And then we're going to replace our cosine of A plus B with cosine of A, cosine of B, minus sine of A, sine of B. Now, whenever you're developing your tangent identities, the one that we want is when the denominator first term equals 1. So when this is a 1 is the identity that we're looking for. There would technically be 4 ways you can write this, but that's the one that is most common, and that's the one they're wanting you to get to. So to make this cosine of A, cosine of B into a 1, you're going to divide it by cosine of A, cosine of B, because those are going to cancel, and that'll just leave you with a 1 for that term. And so you're going to do that for the other 3 terms as well. Divide them by cosine of A, cosine of B. Hopefully you did this last year in pre-calculus. My students, I know, had to do this. Okay, so that's the first thing that you're going to do. And now you're just going to simplify them. So on this one, the cosine of B's will cancel, and we're left with sine of A over cosine of A, which is actually just tangent of A. On this one, the cosine of A's cancel, and we have sine of B over cosine of B, which is just tangent of B. We already made that a 1 because everything canceled out. And then we have nothing canceling here. Sine of A over cosine of A is tangent of A. And sine of B over cosine of B is tangent of B. And so this whole thing would be developing your tangent identity. Okay? So now we're going to develop the identity for tangent of A minus B. So it works very similar to the last one, so if y'all want to pause the video and try it by yourself, you're welcome to. I'm going to go ahead and get started on working it. So tangent of A minus B, first off you make tangent sine over cosine. And then you replace sine of A minus B with sine of A, cosine of B, minus cosine of A, sine of B. And then you replace cosine of A minus B with cosine of A, cosine of B, plus sine of A, sine of B. From there, you're going to again make the first term in your denominator a 1. So we need to divide by cosine of A, cosine of B. And we're going to do that for all of the terms. Okay, so once you've done that, then you can simplify them. So this one, the cosine of B's are going to cancel, and I'm going to have sine of A over cosine of A, which is tangent of A. Whoops. And then the cosine of A's are going to cancel, leaving me with sine of B over cosine of B, which is tangent of B. So we have tangent of A minus tangent of B. These are going to cancel, leaving us with a 1. And then nothing cancels on the last one, but we have sine over cosine, sine over cosine. So 1 plus tangent of A, tangent of B. And so that would be the development for the tangent identity of A minus B. Notice that they look very similar. The only difference really is there's a plus sign and a minus sign. Those get switched. But besides that, they're identical. Alright, so now we're going to look at our double angle identities. This is the sine of 2A, 2 sine of A. There are 3 ways that you can write the cosine of 2A. You can either do cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. This is the one that you want to memorize, or if you're going to pick only one to memorize, I would pick this one here. The other 2 are helpful, but you can always replace either the cosine or the sine, the cosine squared or the sine squared, with the equation that you get from sine squared plus cosine squared equals 1. So you can get to those pretty quickly by substituting in what cosine squared equals or what sine squared equals. And then the one for tangent of 2A is 2 tangent of A over 1 minus tangent squared. So hopefully you've seen those before in pre-calculus. So we're going to develop the identity for tangent of 2A. So again, we're going to say tangent is the same thing as sine over cosine. And then sine of 2A we know is 2 sine of A cosine of A. And cosine of 2A, we'll just use the first one. Cosine squared A minus sine squared A. And then from there, we again want the first term in our denominator to be a 1. So we're going to have to divide everything by cosine squared of A. So 2 sine A cosine A gets divided by cosine squared of A. And then one of the cosines cancels with that to make it 2 sine A over cosine of A, which is the same as just 2 tangent of A. and then cosine squared over cosine squared is 1, and then sine squared over cosine squared is tangent squared. And so that would be your development for tangent of 2a. Okay. Looking at the half angle identities, those are the half angle identities. Last year, if you took me, I said do not memorize these. Don't memorize them this year. These are just something that we're going to use. So if you have to use them on your homework, then we'll go back and find them. But it's not something that you need to know how to develop or need to memorize these at all. You just need to be able to use them. So you just plug in your x and simplify. Okay, so now we're going to look at sketching the graph of y equals log base 4 of x. So we don't know if we plug in a 1 here, log base 4 of 1, and our calculator can't tell us. So what we need to do is put this into exponential. And so some of y'all need it written in this form to be able to do that. Hopefully eventually you'll get to where you can do it when it's written in that form too. But x stays where it is, and the 4 comes over and pushes the y up. So that's it in exponential form. So then you're just going to make a t-chart. But on this one, if we plug in for x, that's not really going to help us. We want to plug in for y. So plug in -1, 0, and 1. Those are always great numbers to start with. So 4 to the -1 is just 1/4, which is 0.25. 4 to the 0 is 1. 4 to the 1 is 4. And so if we graph those, we have -1, or we have 0.5 -1, sorry. And then we have 1, 0, and then we have 4, 1. And so it's an exponential graph, but it goes this direction instead of the normal thing that you would think of as an exponential. So that's the difference between the graph of log or the graph of an exponential. Okay, looking at another one, we want to sketch the graph of y equals negative log base 4 of x. So for this one, we need to move the negative before we change it into exponential. So I'm going to move the negative to the other side of the equation. And then we put it in exponential form, so we have x equals 4 to the -y. And so now we're going to do our t-chart. So we have -1, 0, and 1. 4 to the -1 would be 4 to the 1, which is 4. 4 to the -0 is just going to be 1. And then 4 to the -1 is going to be 1/4, so 0.25. So now we can graph this one. 4, -1, 1, 0, and then 0.25, and 1. So it's an exponential. It's going this direction. And so it looks like that. Okay. So now we're going to sketch the graph for these. And so these are just, we're trying to get the basic shape of them. So part A is what we graphed just a minute ago, log base 4 of x. So it looked like this. It shouldn't be curving away from the y-axis, it should be getting closer to it. But that's the basic shape of log base b of x. This one is what we just graphed, and it was going this direction. It just is the reciprocal of this function across the x-axis. I'm sorry, the reflection of it across the x-axis. Okay, for this one, log base b of -x. That's going to look like that. And then negative log base b of negative x. Does anybody have any ideas? Maybe some of y'all. Oops. Maybe some of y'all thought it would look like this. Hopefully so. That's what it would look like. So that's how you can kind of just know the basic shape of it just based on what it looks like. So now we're going to graph the y equals the natural log of the absolute value of x. This one you can use your calculator for. So you can just plug in ln of absolute value of x. So if we come over here, ln, and then if y'all aren't familiar with your calculator, you may not be aware, but if you go to catalog, you hit the second and then 0 button, that's where catalog is, absolute value pops up right there. There are other ways to get it, but I think that one may be the quickest. But you may have another method that you like better, which is fine. But that would be the graph. But let's say we don't want x, we want 0. Any ideas what the natural log of 0 is? It doesn't work. So anyway, we have a vertical asymptote at 0. But if you plug in 1, you get 0. And if you plug in 2, you get 0.7 basically. So if we come over to our graph, we have an absolute value, a vertical asymptote at 0 because the ln of 0 is not defined. And then when we plugged in 1, we got 0. When we plugged in 2, we got 0.7. And so it's going to be looking like this. And then the same thing on this side because it's the absolute value of it. They should be mirror images. That's not such a great picture. Those don't look great, but that's what it should look like. It kind of looks like that. Okay? Looking at another example. We want to sketch the graph of y equals negative log base 1/4 of x. So again, we have to move the negative to the other side before we can put it in exponential. And then we're going to take our x down, and then it's going to be 1/4 to the negative y. And you can plug them in like this, or if you notice, if we make that exponent a positive, that means we have to flip this fraction, which would make it the same thing as 4 to the y. So you can either plug in here or here. Either way, you'll get the same thing. So if you make a t-chart, and for your for your y values, put -1, 0, and 1, you'll get 4, 1, and 1/4. Sorry, that's not right. You'll get 0.25 for this one, 1, and you'll get 4 for that one. And so if you graph it, we've actually already graphed this one. It looks kind of like that. So that would be the graph of that log function. Looking at one more, we want to sketch the graph of log base 2 of negative x. So if you want to move this over to the other side, you can, or you can deal with it here. The negative x stays where it is, and the 2 pushes the y to the exponent. So we don't move the negative because it's inside of the log here. So when we plug in values for y, 2 to the -1 is 1/2, but then it's going to be negated because x is going to be equal to -2 to the y. So we get -0.5. When we plug in 0, we get -1. When we plug in 1, we get -2. And so if you graph this one, it should look something like this. So there's your graph for that one. So hopefully you remember how to graph all of those and you remember your functions from last year, but that's basically the lesson for today. So make sure that you do your homework. You do get to omit number 21 on your homework tonight, and that's because it says to develop your half angle identities, and I told you we are not doing that this year. So you do not have to do number 21. On your answer key, it should say omit as